Hi, my name is Bill Charbonnet, founder of Large Sense. We're introducing the LS45 Monochrome today. The 4x5 digital back that is compatible with pretty much any lens, and we expect pretty much any camera. Okay, the sensor is 140 by 120 millimeters. 4x5 film. Here's a 4x film sheet pack. The opening is 120 by 96 millimeters. So we're a little bit bigger there than this. I'm going to compare it to a full frame small format camera, which is 24 by 36 millimeters. We're a good bit larger here. So larger sensors give you more of a 3D effect, more solid, more of that large format look you're looking for. We do read the comments you post on our YouTube videos. Last LS911 intro video, you were asking for me instead of Holly, and that is a nice gesture. So this video, it has all me. I do feel more comfortable behind the camera than in front of it. Right now I'm doing both though. Here's a clip from the LS911 intro video with Holly.
Hi, I'm Holly, here to demonstrate how this camera works. I just graduated with a bachelor's in film, but I have never seen anything like this before in my life, so this should be fun.
Okay, let's talk about lenses some. With the LS45, you can pretty much use any lens ever made for large format photography. Here's a projector lens I adapted. Here's a brass pixel lens. Here's the famous Kodak Ektar 7-inch or 178 millimeter. It's a real special lens. Some people use it all the time, and it works fine on the. It covers the custom mount, which is 140 by 120 millimeters. I haven't tried infinity. I don't usually take pictures of stars or anything, but it does cover fully so far, near infinity. Maybe not infinity. It's just 5.5 inches, but it covers a little bit more. And here's a Tessar lens, Carl Zeiss Gen DDR. Here's a bull lens. People compare it to the Ektar. It has smoother background blur than the Ektar. It is also f2.5. With an aperture, it's kind of stuck at f2.5. It is a pretty neat lens though. I did mount it. I did add custom mounts for all these lenses so I can use Nd Filters. I've picked the Wine Country camera system filter system, mainly because its front slot is really tight and light tight for the first filter. I plan to also use this with the liquid crystal shutter we'll be having later. Also, I got their polarizer. It does work pretty well. And their Blackstone Nd Filters. They seem like a really good filter system. I use the 3 different filters, usually cover any situation I have in the afternoon trying to take pictures, with some sunlight in them. Also, some lenses, this will work also, the LS45. If your camera can hold it, it will work. Okay, for the LS45, we're offering 2 mounting options. This is the custom mount, which lets you use the whole sensor size, and there's no sensor in this one, but just to show you, this is the Graph-Lock mount or international standard. This will fit standard cameras. Here's my Speed Graphics camera. Let me get this. So we have a notch here, and this notch fits the slot on the Speed Graphic here. So we put it in, and we need a tool to help secure. This was designed to help it go over the notches here with the Speed Graphic and other cameras. I want to make sure it's nice and tight so it doesn't fall off and crash on the floor. Okay, now it's nice and secure, and you can see now a picture we took with this very setup. Open up the open it up here. Okay, now we'd be ready to go. It's nice and secure, light tight, and it works well with a graph lock camera. Here's another graph lock camera. It's a Toyo View 45G. One thing I like about this one is the rotating back. It's just pretty well made, all around good camera. One possible customer is using this camera, so I picked one up to help do some tests for him. Okay, now we can mount the back on this Toyo View 45. So we look for here we have the notch and the slot. We align them, put them in, then we lock down the tabs. Again, make sure it's nice and secure so it doesn't crash down on the ground or the floor. And here it's nicely mounted on the Toyo View 45. Now our other mounting type is the custom mount. Here we have it mounted on a Swadaski. It's a Polish company that makes these quality wooden cameras at a good price. We've mounted it on the back of their camera. This is actually our color sensor in development, but we can't show pictures, using that yet. So with custom mounting, we laser cut a plate, metal plate that fits onto the wooden back. Now Swadaski will make us custom 3D machined wooden backs that will adapt to our plates. But we'll try to adapt to other camera companies also. Take this off so you can see just like this, the custom back affixes to a plate. Like here, the unused screw holes are to screw the metal plate into the custom back. Right now this white is just I didn't pull off. We do have seals, laser cut seals. This is just a prototype. Laser cut seal would be black and not be out in the open. Now we also got a Swadaski 5x7 camera. So 5x7 is the smallest camera if you want to use the full sensor area. This one we've mounted this back on this camera, and it mounts pretty well. Most of my lenses, of course, use a larger lens board size, so I made an adapter for this one. For any camera, you can use all the movements, swing, tilt, rise, fall, that you would use for film, for monochrome. With color, there may be slightly more limitations of the angle of light, but with monochrome, there's no problem with the angle of light and movements or anything like that. I'd like to mention one thing about the graph lock back. We had to extend the back a little bit to make room for these tabs, so also the sensor needs more space than film. So we're about 20 millimeters behind where the film plane would be. This may affect some wide angle lenses on some cameras. That's something to keep in mind if you do landscapes. Okay, the LS45 is made in two parts, the back and the base. These are the two bases you can choose from. We have the battery powered base, which is lower powered, a little bit slower, and the AC powered base, which is a bit faster. I assume most people are going to want the battery powered base, and it's almost as fast. But if you use the AC powered base, you can still use it outside. Here's a Vagabond Mini. It's made by Paul Buff, and I get about 2 hours with this old battery with this AC powered base, the LS45. Here with this battery powered base, we picked gold mount batteries. The reason why is because they don't fall out compared to V mount batteries. So it's nice and snug, won't fall out. This is the 95 watt hour battery. You can pick different watt hour batteries, bigger or smaller. The main thing is you need the voltage less than 20 volts. We do have a protection circuit which will hopefully stop you from over voltage limits, and it shuts down when the voltage gets too low. Let's look at the connectors on the back of the back. Here we have our AC power input using the standard connector. an HDMI out port. You can view with the external monitor 1920 by 1080. One CF card slot. Now people have been asking for at least 2 card slots, of course. So if you want that, you can. This is a USB 3 drive port. You can plug in another card reader compatible into that port and get 2 CF cards at the same time. You can also write to 2, the same output. Except for video. Video is too fast. You can only write to 1 port at a time. We recommend using a USB 3 drive. Here we have a USB 3.1 M.2 enclosure. This is fast enough for video. Video can be up to 300 megabytes per second. You want something fast, you can plug in this, write to video, unplug, take to your PC and quickly copy over. Files get big quickly. We have 2 Ethernet ports. We have a LAN and Internet. Internet is mostly for our updates of software. We'll be offering frequent software updates. Also, if people want new features, we can add them and you can download them through here. It's a LAN port. You can use it to connect to the camera, transfer files, update settings. Here is the back and the base. Need 2 cables to connect. These are for those 2 cables. There's some power on this 10-pin connector. Do not plug in your Ethernet connectors here. And a little hook ring if you need to help secure your cables. Hi, now we'll show how to take a photo. I connected the cables, the 2 cables between the back and the base. We control the camera with HTML, either through Wi-Fi or a wired Ethernet connection. So you can use any web browser, Chrome, Firefox, Edge, and now I logged into the Wi-Fi. I'm going to type in my password. The default is 1234. This is a PIN number to help keep out naughty people from your network. Okay. When we take a photo, the first thing we usually do is focus. So we have live view that helps you focus. This camera has 2 shutters, so both are open. I go to the widest aperture, and then I'm going to try to focus. Let's go to live. Okay. Now we're in live view. I'm going to change the exposure to try to be 1:1. So live view, you get the exposure gain of 1. That'll show you the final exposure results. So we'll go to live view, and then we can view our subject. Typically you focus by moving the subject, moving the camera, or moving the lens here. Usually I get the lens in the near the right spot. It's a little dark. We can for focusing, you can also select your own curve that applies to the linear file. So when digital takes pictures, it comes out pretty linear. Then you apply a curve. I'll try standard plus the curve I made. You can make your own curves in Photoshop and save them as actions. It will read Photoshop actions. We'll talk about that in another video. So here on the screen, you can click to make the object full screen. You can zoom in to 100%. You can zoom to 400%. I usually use 100%. Okay, now I usually try to focus on a close eye. There's a little latency here, so you have to be careful with the latency. But it's not too bad. Okay, focus on the left eye. Okay, well, let's move the cat a little bit. Yeah, that's pretty good. Okay, go 100%. The cat's a little on the dark side. It's a backlit cat, so I'm going to add a flash turn the flash up a little bit. Okay, now let's exit live view. Okay, exit live view. Now we're going to go to the still photo side, and we're going to take a test picture. Snap. Oh, there. That's pretty. That's a pretty good picture. You can view full size, zoom in, look at your picture. So yeah, so you can zoom in, move around, check out details. Okay. Now before we take our actual picture, oh yeah, I'll let you know there's different ways to take a picture. You can use the mechanical shutter here. It's a nice shutter button. You can, if you don't want to vibrate the camera, you can use a remote. This is a 2.5mm port and just a mechanical switch. Take a picture. So the camera takes about 1 frame per second now. Later we can speed it up if that's an issue for people. So you can be a large format paparazzi and going around taking pictures at around 1 frame per second. Okay, now when we take pictures, usually we have we need a dark frame and a flat field. The sensor actually produces a lot of noise, but it's mostly fixed noise, fixed pattern noise. So this is noise that's easy to subtract, and you get a really clean image, cleaner than other cameras at short exposures. Take the dark frame. Right now we were in auto dark. Auto dark is convenient, but not as good as a real dark. So we'll turn off auto dark. We'll take a dark frame. Now, dark frame, accept it. Okay, the dark frame looks bad. That's because we have auto contrast on, and there's so it's actually pretty. We have some this particular sensor we're using for testing has some bad lines. They're showing up a little bit brighter, throwing off the histogram. So this is a flat field box. It works better for bigger lenses, and this LED panel. The LEDs are kind of bright and these little in their spots and darken where they're not. So we have this diffusing filter that works really well. So I'll try the flat field with this LED here. We hold it close to the lens so it's all nice and blurry. And we get a little too dark there, so yeah. Okay, we're going to take our flat field with, make sure our shutter's open. Sometimes you may forget that. I know I do. Okay, so we're going to, after all I can guess, we're pretty wide open here on this f4.5 lens. Okay, let's try one. We hold it close to the lens so it's nice and blurry. 100%, that's too bright. So at 100%, your flat field's not going to work. Flat field does lots of things. It finds dust. So 100% the dust will be blown out. You need to be down so you can capture the dust on your image. I'll hold it back a little bit here. You got a good flat field. We want to make sure that it's not fully exposed. And our system, you can look at the raw histogram, which is nice. And we have a gallery here, so you can review your pictures of your cats. Yeah, we have a gallery function, so you can look at all your pictures. And if you just save them, you can download them to your device. You can review, go full screen. Also, other people, you can have multiple users using the system at the same time. So, check the histograms. So, one person may be reviewing images while the other person's taking images using different devices. So you can connect, I set up for 100, but you can connect maybe more if you need to. If you like a picture, you can add a star to it, and theoretically that should show up in Windows and Lightroom. It should be working by now. So when you import to Lightroom, if you do, oh, I think I rotated. Or you can also rotate your images. So you can you have one mode if you want to use your phone as a shutter button. Most of the screen, just scroll up. Most of the screen then becomes a shutter button, so then you can take pictures easily without looking at your phone, as the whole screen is the shutter button. Okay, wrapping it up. Got a few things to say. Later we'll make more videos about camera operation. And right now we're talking about file types. So we have a special file type called LSR1 that saves all the elements of an image. So we call it raw. It's more than what other people raw have. We also can save as DNG. We can save as TIFF, 16 bits with curves, or a linear TIFF, 16-bit. And we always save JPEGs, partly so we can, the JPEGs are also used for previews in the gallery. So JPEGs are automatically saved 8-bit, pretty decent compression. Now the LSR1 format. Most cameras don't give you all the files that make up an image. So every sensor has some defects. We save the raw sensor readout, and then we save a defect map. You can edit the defect map, you can add your own. Right now we're using a neural network in painting process to remove defects from images. It works really well. And also we save a flat field, the ones that you take, the dark field, curves. We save all the curves in the camera, every LSR1 file. So perhaps you picked one curve when you were taking the image. Later on the computer, you want to change curve to another curve you had on the camera. They're all saved with every image. We also save the EXIF and other settings. I didn't mention before in this video, but we do have a EXIF function that lets you edit your settings for EXIF. We also have an enlarging feature that enlarges about 4 times the pixels. It works so well, it's almost better than the original. I don't know, it's pretty amazing. It's also a neural network based deep learning method. So the graph lock 5.4 megapixel becomes 21.6 megapixels. The full sensor readout 6.7 becomes 26.8 megapixels, and it is a bit slow, this process, so we don't include it on the camera. It's on our external software. Because it's so slow, we have an option to use NVIDIA GPUs to do the processing. It may not be that critical for if you take a few pictures, as a typical large format user might. It's really critical if you're doing videos. If you take thousands of images, you need to process them. If you're doing professionally, you probably want to get a really nice NVIDIA GPU card, and this will really speed up the processing. So it does have a CPU only mode. If you don't have NVIDIA's GPU, CPU only mode, yeah, it runs it takes a little while depending upon your CPU. Now, showing our included, we offer a desktop GUI that helps process the LSR1 files, and you can export them as TIFFs or DNGs. In our software, this handles the enlarging, the really quality enlarging. It also helps, you can edit special features of the flat field. We have a really good dust removal system, and it just also takes some time. So you may wish to turn it off in camera. Later on your computer, you can process the dust maps. So you have different settings. You can make the dust map stronger or weaker. If you got sometimes get a lot of dust. You should keep your sensor clean. You should keep your lenses clean. But mostly this is for dust on the sensor or on the cover here. and it is a really nice dust removal system. If you need to take a good FFC flat field. And finally, thanks for watching this video. We're gonna have more videos about camera operation. This is just the version 1 of our LS45 intro videos. Later, we're gonna remove this video and record it in a little bit better quality. So, kind of getting this out there, letting our mailing list people know that the LS45 is ready, the monochrome version. We're still working on color, and color, everything works pretty much the same. So later on we'll also have a video about videos, how to take videos, and they'll include our liquid crystal shutter, and we'll have videos more. Some people have asked to take, instead of, typically the camera's made for tripod operation, using on a tripod nice and steady. Some people did ask for point and shoot, hand holding pictures. So for that, we'll make a special video how you can do that. And it is possible, but typically, tripod mounting. If you're at a really shallow depth of field, you're not going to get in, the front of their eye in focus if you're hand holding. So probably that's where f8 and be there came to be. And that's all for now. I hope you enjoyed the video. Look forward to our videos in the future.